Okay, welcome to chapter 10.1 Triangle Theorems. Before we even begin on this chapter on triangle theorems, there are some things that you should go and revise before embarking on this chapter. The first thing, right, is proofs for similarity for similar triangles. Okay, if you want to revise on this, you can either look at your E-Maths textbook 3A, go and look for the relevant chapter. Okay, go and read through the proofs for similarity. Or in your A-Maths textbook, alright, you can actually look at page 242. Alright, let me show you page 242. Right here, 242, there's all the tests for similar triangles. Similarly, for congruency, either you can look at the E-Maths 3A textbook, you can dig it out from your cupboard. Okay, or you can look at page 240 of your A-Maths textbook, and these are the tests for congruent triangles. Alright. And finally, there's the midpoint theorem. There's a video attached to this chapter, so you can watch the video titled Midpoint Theorem. Okay, and if you want to read more about the midpoint theorem, you can actually look at page 243. Okay, page 243 over here. Okay, they will talk about the midpoint theorem. And now I'm just going to dive in, alright, into the exercises, okay, which is exercise 10.1. I will first start with question 3. And this is found on page 245. Okay, first and foremost, question 3, page 245, we show this here. In the diagram, it is given that triangle BOA is similar to triangle BYT. First thing to prove that AB is to BO equals to BT over BY. Okay, and second one, BAT is similar to triangle BOY. Okay, in order to prove that AB over BO equals to BT over BY, alright, what I can do here is this. For part 1, I will first use the relationship they've given me where they say that triangle BOA is similar to triangle BYT. So if you look at the question, right, what they wanted you to prove is AB over BO equals to BT over BY. So probably, right, it involves triangle ABO, okay, because AB over BO, and triangle BTY. So what we do is, by similar triangles, I will know that AB, this one we use the vertices, AB, okay, 3 and 1 over TB is equals to, now we have a decision to make. Shall we use AO or shall we use OB? Okay, think a while and look at the question. Okay, it involves BO, alright, so I shall use BO. So I have BO over BY. All this is by using the property of similar triangles where the corresponding sides have equal ratios. Okay, so AB over TB is equals to BO over BY. So now what we do here is we just have to rearrange. So AB over BT, we write it in the form that the question wants, is equals to BO over BY. Then we have to rearrange. Now we multiply both sides by BT and BY. So what I get is AB times BY is equals to BT times BO. And finally, if I divide both sides by BO and BY, so I divide by BO and BY, we just rearrange, we get AB over BO is equals to BT over BY. Okay, which is what the question is actually looking for, and this is proven. Quite simply, question 3 is done. Now we will look at question 3 part 2, where we are asked to show, okay, or to prove that triangle BAT is similar to triangle BOY. Okay, if you look at your diagram, BAT and BOY, alright, straight away you can tell, okay, BAT and BOY, straight away you can tell that they are a pair of angles that are equal. What are they? Is these two angles. And by what property? Something we learned in primary school is called vertically opposite angles. So for the proof, we already have a pair of angles that are equal. So I will first start by writing, okay, angle ABT, is equals to angle OBY. And the reason here being vertically opposite angles. Okay, then now, usually when we prove similar triangles, most of the time it's angle, but in this case, it is not. Okay, so not to worry. Okay, we can use the what I call the relationship that is given above. Okay, so from part 1, I know that AB over BO is equals to BT over BY. Okay, how does this actually help us? Okay, in this case, we know that the corresponding sides of similar triangles have a equal ratio. So if you notice, okay, from here, AB is to BO is equals to BT is to BY. Okay, ABBO and BT and BY, alright, they have the equal ratio down here. So therefore, I have two sides, okay, that have equal ratios, AB, BO, BT and BY, and I also have a angle, okay, that is equal. So therefore, I can say that, hence, triangle BAT is similar to triangle BOY. Quite simply, and this one, the reason will be SAS, side angle side similarity. Okay, and I'm done already. That's all I need to do for question 3. Okay, stay tuned for the next video where I'll go through question 5 and question 7.